Hey Algebra 3 students. So here's a video that takes you through how to solve some triangles that are not right triangles. Okay? There's two laws I'm going to go through in this video. The first one, the law of sines, allows us to solve triangles that are heavy on angles. So if we're provided with two or more angles, when we're asked to solve the triangle, we'll use the law of sines. The law of cosines allows us to handle problems that are heavy on sides. So if you're given two or more sides in the problem, we generally will use the law of cosines. All right? So these are two laws that we use to handle triangles that are not right triangles. If the triangles are right, we'll use SOHCAHTOA or use the Pythagorean theorem to help us on our way. We can't use those if the triangle is not right. All right? First of all, law of sines problem. Again, heavy on angles. We're provided with two angles. All right? The law of sines says this, that the sine of any angle in a triangle divided by the side opposite that angle is in the same proportion throughout the triangle. So in this case, the sine 34 over the side opposite 34 degrees, so 4.86, that fraction, that proportion, is equal to the sine of 26 over this side, all right? Which is also equal to the sine of this angle over x. Now, because we're looking for x, we don't really care about the angle of 26. What we do need the 26 for is 26 and 34 make 60. So this angle here must be 120, right? So now we know that sine 120 will be the numerator in that fraction, all right? So this is the equation we have to solve. Sine 34 over the side opposite it equals sine 120 over the side opposite it. So the only reason we needed 26 is to find this angle. And we needed that angle because the x was over here. The x was opposite that unknown angle. All right? So that's the equation we'll set up. As you might remember from back in the day, other classes, when you're solving a proportion equation, we cross multiply. All right? So now we'll get sine 34 times x, or x times sine 34, equals 4.86 times sine 120, and now we get out the calculator. All right? Because now we'll be dividing both sides by whatever sine 34 is to solve for x. All right? So on the calculator, we can type in 4.86 sine 120. I would recommend then hitting enter. So just doing that. 4.86 sine 120, hit enter. And now, just divide that, so just hit divided by, and now you can type in sine 34. Sine 34. You could do it all in one step if you use parentheses appropriately, but this is probably a safer way to do it. And let's round to the nearest tenth. So what do we get? 7.5. X is approximately 7.5. All right? So that is just what we would do to find x. Now, if we were asked now actually to find this missing side, say it was y, all right, an equation we could use to find y would be kind of the same idea. Sine 34 over 4.86, that same fraction again, equals sine 26 over y. I know I didn't ask you to do this, but just to kind of show you, again, we can use the law of sines again to find side y. We would not be able to, knowing that x is 7.5, just to be very clear about this, we would not be able to use the Pythagorean theorem to now find side y, right? We could not do this squared minus this squared equals, we couldn't do that because the triangle is not right. So we'd have to use the law of sines again and do cross multiplying to find y, all right? So I just wanted to make sure of that. So that's how we would use the law of sines. Simple, just to cross multiply, not a big deal, all right? The law of cosines is a little uglier. All right, law of cosines, and there are many more mistakes made with the law of cosines because the formula is kind of messy. All right, what the formula says is the length of any side of the triangle squared, any side, doesn't matter which one, it's not a right triangle we're talking about anymore, equals the sum of the squares of the other sides minus 2 times their product, 2 times b times c, times cosine of angle A. All right? So it's a messy formula. And we can use this to find missing sides or missing angles. If we're looking for a side, a missing side, that's the side that's going to be by itself over here on the left. Whatever side we're looking for squared will be on its own side in the equation. If we're looking for an angle, that angle is variable. Obviously, we'll go at the end. What we'll start the problem with, though, is the side opposite that missing angle. All right, so let's do two examples. One where we're looking for the side, one where we're looking for the angle in a law of cosines problem. All right, with law of cosines, we want to find the, we've got the setup. Wow, the setup of the problem will be either we're given all three sides or two sides and an angle. All right, so this, if the problem is heavy on sides, we're going to use law of cosines. So here's the problem. All right, you're given triangle ABC. Side length of A is, let's draw a triangle here. So triangle ABC. Side A is 8, so we'll label it 8 over there. Side B is 9. And angle C is 20 degrees, and we're looking for side C, which is over there. All right, so again, not a right triangle, or at least we don't think so. We've got to find side C. Because we're looking for this side, so this I'll call it problem 2, I'll say find the length of side C. That should be a lowercase c. All right? Because we're looking for that side, we'll start the equation with c squared. All right? That side by itself squared equals the sum of the squares of the other two sides, doesn't matter what order you go in, minus 2 times their product, so 2 times 9 times 8, times cosine of the angle that is opposite the side we're looking for. Okay? So c squared equals all this stuff. Now the nice thing is, all this is just on the calculator as one number. So what I would do is, I would just type in, I mean you could do it carefully in 81 and 64 and so on, but I would just type in 9 squared plus 8 squared minus 2 times 9 times 8 times cosine 20. So you can't really see the whole thing because it kind of gets cut off. Maybe if I can scroll over, maybe you can see it. No, I won't let you. All right, but that's what I typed in. Now that is what c squared equals, right? So c squared is approximately 9.68. So on the paper, if you wanted, you could even write c squared equals 9.68 or 0.684. But on the calculator, we'll just use that uglier decimal and just square root it. Right, so second x squared, that value, and we get the answer. It's just about 3.1 if we're rounding to the nearest tenth. All right, so that means c is approximately 3.1, which we got by square rooting. Right? So that's the process. All right. With this kind of problem, you don't need to show me this middle step. You can just show me the original equation. You've got to show that, and then you can use your calculator to find c. All right. It's a messy formula, but we have calculators, so you've got to bring a calculator to class. Make sure you have this with you. Otherwise, it's going to be a pretty messy problem to do by hand. All right? So, c is 3.1. Right. Now, let's do a problem where we're looking for an angle. In fact, let's use the same problem, and now that we have all three sides, let's just say, instead of find c, let's make it problem 3, and say find the measure of angle A. Okay? So, because we're looking for this angle now, we do need all three sides to do this. So we would first need to find side C to do this. All right? Because we're looking for the angle, we're now going to start the equation with the side opposite that angle as our lone value by itself. So 8 squared is how we would have to begin if we were looking for angle A. 8 squared equals 3.1 squared plus 9 squared minus 2 times 3.1 times 9 times cos A. All right? Now, this is a little more challenging, all right, because the A is all the way over here. Okay? This is where a lot of folks make mistakes if they're not careful, when you're solving for an angle with the law of cosines. All right? So pay close attention. I'm going to start, if you think back to like a pre-algebra problem. What would you do if it was just like 6 equals 2 plus 15 minus 2x? How would you solve that? Because that's really what's going on here, right? You have some number equals the sum of two numbers minus some coefficient. This times this times this is the coefficient on cos A, right, on the variable. So we have number equals number plus number minus coefficient on x. Well, you would do one of two things. You could add these up first and then subtract. You could also subtract them separately. 6 minus 2 is 4, minus 15 is negative 11. Regardless, you subtract this and this over, and now you divide by that coefficient of negative 2. All right? Divide by negative 2, divide by negative 2, you get positive 5.5. All right? Same kind of idea. We're going to start by subtracting, and then dividing by whatever coefficient that becomes. Okay? So it's a little bit messier. And then because we're solving for an angle, if you remember this, we're going to have to use the inverse key on the calculator as the final step. All right? So you don't need to show me that much work on your paper, but I'm just going to do 8 squared, 64 of course, minus the 3.1 squared. Now that was approximate, right? So it would be better if you used the more exact value in your calculator. Okay, but if you're showing work, I'm not going to take off points if you use the rounded value in this problem. It's okay. 8 squared minus 3.1 squared minus 9 squared. That's how I started, just by subtracting off those two squares. All right? So we're now at the point, this is about negative 26.61 equals. Now I'm going to do negative 2 times 3.1 times 9. And I got negative 55.8. That is the coefficient, this whole guy here, that whole product, is the coefficient on cosine A. All right? This equals this times cos A. Now, we're solving for A, so we've got to divide both sides of that coefficient. So I'll do negative 26.61 divided by negative 55.8. And I get this, 0.47 whatever. All right? So I just divided both sides. I'm showing you every step on the calculator and on the board. All right, so this is approximately 0.4769. But on the calculator, I'm going to do now the inverse cosine of that number, right? We're looking for the angle. So angle A is going to equal the inverse cosine of whatever that is. And we get approximately, let's see, second cosine of that, we get 61.5, just about. So that just shows us that angle A is about 61.5, all right? So I think it goes to show that the first law of cosines problem I did was easier, right, than the second one. When you're looking for an angle, you've got to be a little more careful, all right, when you're using the calculator. Whereas when we're looking for a side to find the 3.1, it was a little bit faster, all right? So you have 3 examples here. Now we're going to do a lot of problems where you've got to use law of sines and law of cosines. All right? First of all, you got to know when to use which. And I went through that earlier in the video, right? If we give you a bunch of angles, right, at least 2 angles, you're going to use law of sines. If you're given at least 2 sides, you're going to use law of cosines. All right?